4.5, Day 11 Notes. We're still talking about E. We're looking at a couple applications of the number E. And there are only 2 examples in these notes, so they're pretty short. So applications of E. Compound interest especially. If you see the words compounded continuously, you know you need to get E. So the first example, so we have an investment that grows at a 2.323% continuous yearly rate. So when you see the word continuous, and we're talking about interest, you need to go ahead and start thinking about how we can plug this into the continuously compounded interest formula. So you know there's going to be an E involved. Okay? So my question is, can we find the effective annual rate for this investment? Okay, well, so this 2.323%. When we write this as a decimal, that's going to go in the exponent for our continuously compounded interest for that formula. Another name for that is just the continuous growth rate. So that'll be in the exponent. It'll be e to that power times t. So that's the continuous growth rate. We are interested in finding the effective annual rate. So we're going to be able to calculate that. Let's go ahead and set up the balance in the account. The initial investment, we don't know the actual value of this initial investment, so we'll just say P. And then we have E, because it's compounded continuously, to the 0.02323. So write that as a decimal. And then I would put T here, but since we're interested in the effective annual rate, that's for 1 year, we know T is going to be 1. So the T value there, there we go. Let me go ahead and color code and underline the right thing. The effective annual rate is what we're interested in, so let's consider it for 1 year. So there's our formula. Continuous growth rate, that's in the exponent. So the effective annual rate for 1 year, we really just need to calculate e to this power. And that'll tell us what the initial investment got multiplied by, so that'll tell us the percent, or the annual percent. So let's see. In blue there, that's what we're going to focus on. So we can calculate that pretty easy, and I just took it to 4 decimal places here. So this is approximately P times 1.0235. So in 1 year, the investment gets multiplied by this. So what's the percent increase or percent growth? That's our effective annual rate. Well, all you have to do is compare this to 1. How much bigger is this number than 1? 1 would be like 100%. So now this has grown to 102.35%. So that's how you read that. I focus on this color in like the gold color here. The effective annual rate would be the leftovers. How much bigger is it than 1? That's 2.35%. So if you'll notice, that's bigger than what we started with for the continuous growth rate. So that's bigger than our continuous yearly rate, or the continuous growth rate, which was 2.323%. So it is almost equivalent to like the nominal rate again. It starts there, it's fixed, but once it gets compounded, the interest rate and what you earn gets bigger. So for these kinds of problems that ask for the effective annual rate, and you're using an equation with E in it, you're using compounded continuously, well, let's just assume the year is 1, so we can find the annual rate, and then just calculate e to this power. And then you can have the growth factor, and from there, you can just say what the effective annual rate would be. All right, second example. Which account is better? So I'm going to give you 2 accounts. They both have different interest rates. They're compounded differently. I want to know which is better, and obviously we have to prove which one's better. So the first one gets 8% annual interest, and it's compounded quarterly. Not a bad investment option. The second one gets 7.95% annual interest, but it's compounded continuously. So how do we make a comparison on which is better? Well, we're actually going to do something similar to the first example. We're going to find the effective annual yield for each account, and the higher one, well, that would definitely be the better one. So in purple here, I'm color coding. Let's do the 8% account. So 8% annual interest, that's compounded quarterly. So I go to my compound interest formula, and my rate is 0.08, quarterly is 4. And since I'm going to focus on 1 year, like the effective annual rate, I'm going to plug in 1 there for my t. So that's 1.02 to the 4th power. So it gets compounded 4 times in a year at this rate. So the effective annual, so it increases a little over 8%, like 8.243% is what the increase would be. And we should be able to read that from here. Just make a comparison. How much bigger than 1 does this number end up being? Well, this 0.08243. That's our effective annual rate, or effective annual yield, which is 8.243%. Okay, so that's for the 8% account. How about for the 7.95% continuous account? So the balance of my account, I don't know the investment, it doesn't matter, so I'll just put P there for that. And then for compounded continuously, I need E to the K times T, or to the R times T, if you will. E to the R, so in this case the rate would be 0.0795, and since we're going to compare the effective annual rate, I'll just put 1 for the year. Okay, and then if I can calculate this, this will give me like my B value, my growth factor that I can compare and get the effective annual rate from. So that's something we can do in the calculator pretty easily. So I'll approximate it to 4 decimal places here, 1.08275. So the effective annual rate for this one, it's actually a little bit bigger. 8.275%. That's how much bigger this is than 1. So for all of these, when I find that rate value, I'm just comparing it to 1 and seeing how much bigger it is or how much smaller it is than 1. So there you have it. Who's the better account? In this case, it's 7.95% compounded continuously, that account. All right, that's all for these notes. I'll see you in class.